Good morning, students. Now we are discussing last chapter in Unit 3. The topic is just the advanced water treatment regarding removal of color and odor. Guys, actually, just this is the matter I got from the different search engines. So, how to remove color, odor, and taste from water? Here, guys. Guys, here uh, in this article we will discuss about how to remove color, odor, and taste from the water. Here, erosion, uh, erosion. Erosion is a process in which water is brought in intimate contact with atmospheric air to promote exchange of gases between water and atmospheric air. The aeration of water serves the following process. Here, the point one is in the course of erosion, oxygen from atmospheric air is absorbed by water, thereby oxygen deficiency of water is eliminated and also freshness freshness is imparted to water. Second point is carbon dioxide, hydrogen sulfide, and other volatile substances imparting taste and odor to water are easily expelled by aeration. Iron and manganese present in water are oxidized to a certain extent by erosion. The following four types of aerators are generally adopted for erosion in the treatment of water, particularly removal of color and odor. The first one is the guys here. The first one is the diffused air aerators. Diffused air aerators. A diffused air aerator consists of a tank or a basin in which at the bottom perforated pipes are provided. The water to be aerated is filled in the tank and compressed air is blown through the perforated pipes. The air bubbles emerging from the perforations rise up from the bottom of the tank. While rising up, the air bubbles come in close contact with water contained in the tank, and aeration of water is thus achieved. The tanks are generally 3 to 4.5 meters deep and 3 to 9 meters wide. For effective mixing of air and water, ratios of width to depth should not exceed 2:1 ratio. The tanks work on the principle of continuous flow with detention period varying from 10 to 30 minutes. The amount of air required ranges from 0.06 to 1 meter cube of air per 1000 liters of water treated. The diffusers are located on one side of the tank, and the second one is the cascade aerators. Cascade aerators. Guys, in cascade aerators, water is allowed to flow downwards after spreading over inclined thin sheets, and the turbulence is created by allowing water to pass through a series of steps or buffels. The number of steps is usually 4 to 6. Water is allowed to fall through a height of about 1 to 3 meter. In this case, removal of gas varies from 20 to 45% of carbon dioxide and about 35% of hydrogen sulfide. And the third one says the spray aerators. In the spray aerators, In spray aerators, water is sprayed through nozzles upwards into atmosphere and broken up into either a mist of droplets. The installation consists of a fixed nozzles on a pipe grid and trays for collecting the spread water. Nozzles usually have diameters varying from 10 to 40 millimeters, spaced at intervals of zero point 0.5 to 1 meter or more. The pressure required at the nozzle head is usually 7 meter of water, but it may vary from 2 to 9 meter of water. The discharge rating for nozzle varies from 18 to 36 meter cube per hour. Spray aerators are usually quite efficient with respect to gas transfer and can remove 70 to 90% of carbon dioxide and 90 to 99% of hydrogen sulfide. And the fourth one is waterfall or multiple tray aerators. A waterfall or multiple tray aerators consists of number of trays with perforated bottoms arranged vertically in series. Water flowing through a riser pipe is discharged through perforated pipes into the topmost trace and after flowing down through each of the lower trays. It is collected in a basin provided at the base. During the downward flow through trace, water comes in contact with atmospheric air and thus aeration takes place. Usually trace about 4 to 9 in number with a spacing of 300 to 750 millimeters are provided. In most aerators, coarse media such as coke, stone or ceramic balls ranging from 50 to 150 millimeter in diameter are placed in the trace to increase the efficiency of aeration. With the media, good turbulence is created and large water surface is exposed to atmosphere, resulting in an increase in the efficiency of erosion. The provision of media is also beneficial for removal of iron from water. The removal efficiencies of these aerators usually vary from 65 to 90% of carbon dioxide and 60 to 70% of hydrogen sulfide. Treatment by activated carbon. Here, activated carbon Activated carbon is used to remove color, taste, and odor from water. Activated carbon is produced by heating a carbonaceous material such as coke, charcoal, paper mill waste, sawdust, and lignite examples. In a closed vessel at a high temperature, it is then activated or oxidized by passing air, steam, or carbon dioxide, chlorine, or flue gases. The activation of the carbonaceous materials removes the hydrocarbons which might interfere with the absorption of organic matter. The activated carbon is available in various trade names such as Darko, Nuchar, and Minchar. It is available in granular as well as powder form. The grains are of 6 millimeter size and below. Its weight is 4 kilonewton per meter cube and it is highly porous in structure. Activated carbon removes organic contaminants from water by the process of adsorption. In, ab- in adsorption, high surface area is the prime consideration. Granular activated carbons typically have surface areas of 500 to 400 meter square per GM. Methods of application. Activated carbon can be applied to for treatment of water in two ways, as filter media, as fine powder feed. Guys, here as a filter media, a bed of granular activated carbon is placed instead of a sand bed in the rapid sand filters. The activated carbon filter bed is supported on a graded gravel bed. Filtered water is passed through the bed of activated carbon. This will remove taste and odor uh, from water and will also absorb organic compounds. With the continuous use, the activated carbon losses its adsorptive power. It is then required to be rejuvenated. The rejuvenation of activated carbon bed is carried out by passing live steam into the activated carbon bed through perforated pipes which are placed in the gravel bed of the filter. The process of rejuvenation may have to be carried out at intervals varying from 1 month to 1 year depending upon the quality of water treated. In powder form, activated carbon may be applied to water at various stages of its treatment as indicated below. It may be added to raw water before any treatment is carried out. And second one is it may be added along with a coagulant in mixing tank. Excuse me, guys. It may be added along with coagulant in mixing tank. Third one is a portion of activated carbon may be added in mixing tank and the remaining portion may be added to water just before it enters filter. This is known as a split method. It may be added just at the point where water enters filters. It may be applied at constant rate or at varying rate. In the latter case, the rate of application is high when filter is washed and it becomes lower and lower as filter gets clogged. The usual dose of activated carbon varies from 5 to 20 ppm. However, the optimum dose of activated carbon may be, may be determined on the basis of test results. Activated carbon treatment has the following advantages. It helps the process of coagulation if adopted before filtration of water. It reduces the chlorine demand of treated water. It removes taste, odors, and colors caused by the presence of excess chlorine, hydrogen, sulfide, phenol, iron, manganese, etc. It removes organic matter present in water. It is effective in preventing or retarding retarding the decomposition of sludge in sitting basins. Its overdose is harmless. Use of copper sulfate. Copper sulfate CuSO4 is the chemical composition is used to serve the following two purposes: removal of color, odor, and taste from water, control the growth of algae, bacteria, and some types of aquatic weeds. Copper sulfate is available in powder form or crystal form. It is easily soluble in water. It can be applied either in the distribution pipes or in open reservoirs. In the former case, a solution of copper sulfate of required strength is prepared and it is added just at the entry of water in the distribution system. In the latter case, copper sulfate may be applied in one of the following ways. The crystals of copper sulfate are ground and converted into powder, and this powder is sprinkled on the water surface in a reservoir from a moving boat or an aeroplane. The crystals of copper The crystals of copper sulfate are placed in porous bags, and these hacks are attached behind a moving board. Solution of copper sulfate of required strength is prepared and it is spread on the water surface in reservoirs from a moving board. The usual dose of copper sulfate is about 0.302 0.65 ppm. Such amount of copper sulfates does not make water unfit for drinking purposes or for industrial purposes, but it may provide determinal to certain types of fish. Thank you guys. So today we completed successfully second unit in wastewater management. So now in next class I will teach the unit 3. Thank you guys.